Well, hello from Emerald Hill Skies. This is Doug Lucas. We're at the outskirts of Louisville, Kentucky here, and we're ready to start Messier Marathon. And, we thought the clouds would just be all over the night sky tonight. But I'm happy to tell you that rumors of the clouds were largely overcooked. As it turns out, this is M79. It's our first object, and we're just going to start right into our workflow here. M79, of course, is a globular cluster. Got all these beautiful little yellow stars. I'd like to welcome the folks who came by just in case, people like Dave and Ricky and Chris and Junk John. Great to have you guys aboard. Sorry couldn't give you more notice, even as late as 6 and 7 o'clock. The forecast was solid clouds until 4 a.m. Didn't look like it was going to be worth it. But as it turned out, it all went away, and we've got nice clear skies now. So we're going to say lots of yellow stars and
observation logged.
Okay, and that takes us to the next object, which is going to be M52. Aaron, good to have you aboard. Welcome. Junk John, you hung around. You guys are brave people to hang around like this. I feel bad that we told everybody that it wasn't going to happen, and now it's happening. So you guys are familiar with the Messier list. This was originally done by a guy named Charles Messier. There's a nice little picture of him. Hello, Charles Messier. And Messier was hired by an observatory in Paris, France. His goal was that they asked him to chart some comets, and especially to be on the lookout for Halley's comets. So he started looking at all those skies. There you see our open skies. Tonight you can see the light pollution from Louisville, Kentucky, but we're running a Celestron light pollution filter that's designed for the RASA 11. Our RASA 11 is in a PureTech observatory with a roll-off roof, and it's sitting there on a PureTech movable height pier, and we're using a ZWO ASI2600MC Pro camera with it. So anyway, Messier was charged with trying to find maybe the return of Halley's Comet. And the trouble was they gave him the wrong address in the sky. So as much as he would try to look for it, he wasn't having any luck. And that was sad. But what was good is that along the way, he started noticing things that got in his way. Things that looked kind of like comets, but he kind of wished that they would just be gone. So what he did is he started a list of those fuzzy objects that were sort of distracting him, and they looked like comets. And he said, these are things I don't think anybody will want to go back to because they don't have anything to do with comets. But you guys know the history of the story. Tiffany, you're on. Well done. Stu, good to have you on from Tauranga, New Zealand. What happened was, if you know the story, he started this list, and he did it in the order that they got in his way. And the first thing that got in his way was M1 and so on. So these number objects are not in any really good order. You know, the number 52 doesn't represent anything other than the fact that he happened to cross this. So we're just going to make a quick observation here. The Cassiopeia salt and pepper open cluster was looking exactly like salt on the counter. He started this list, and I think originally
Observation logged.
he really just saw, I wonder what that is down there. I know we don't want to get distracted, but let's go over to Stellarium, and you know what we can do? Now we can say Control 3 and Stellarium automatically syncs with Astroplanner. Takes it just a second to load when I've had the
M52 selected.
There we go. Thanks, Pete, for helping me get all this set up. That's the Bubble Nebula. How interesting is that? I love the Bubble Nebula. See, it looks like a little Christmas ornament on there, doesn't it? Wow. Let's put our field of view on there so we see exactly what our telescope is seeing. Sure enough. Now back to the live view. So that's the Bubble Nebula. Now let's just zoom in on it real quick. Wow, isn't that cool? Let's make the sky a little bit darker and bring up the mids a little bit more. Wow, so you can already see the bubble popping out after just 2 minutes. Man, if we could hang out there, we could see a beautiful bubble there. But you know, this isn't on Messier's list. It didn't make the cut. And keep in mind, he was observing from urban Paris. So he didn't see dim things like that. He just saw these smudges from things like open clusters. So tonight is all about Messier. Let's stick to our plan, since tonight is Messier night, Messier Marathon. Off we go to M103. Let me catch up with you guys here. Tiffany, so glad you're here. Welcome from California. Ricky, good that you're here too. You can see the scope there. And then as soon as we get, this is going to be M103 now. You know, we really don't need to, live stack all of these, but we really don't need to plate solve all of them either. That's just taking up time, so we'll adjust that workflow as we go. Wow. This M103 also goes by the name NGC 581. These new general catalog numbers were assigned later, and indiscriminate of whether they were on a Messier list or not, they were placed in the NGC catalog. So some of these objects have more than one designator. This is the open cluster M103. Looks kind of like a wedge, doesn't it? Thanks to Pete over on the Isle of Wight, who helped hook all these things together with all these cool scripts. Looks like a wedge.
Observation logged.
Okay. So when we do the sequencer this time, let's don't do the default. Let's try next target without plate solving. And let's hunt over to the Little Dumbbell Nebula. This is the Little Dumbbell Nebula. This is M76. And again, we can see these in Stellarium by just going, we've got a little keystroke, a little shortcut key, thanks again to our friend Pete over on the Isle of Wight. Pete got us hooked up.
M76 selected.
So that's the Little Dumbbell Nebula. It's a planetary nebula that shows us what happens when a star begins to die. And it ejects that material out, and the star's gravity still kicks in and sometimes creates polarity among the ejecta that it has shot out. And this ejecta can take the form of sometimes oxygen, sometimes hydrogen, sometimes just lots of carbon leftover stuff. You can see the red down here in the stellarium view. Let's go over to the live view now. Okay, so there it is, right in the middle. And we are stacking images. And what the stacking lets us do is gets rid of some of the light pollution over time, because the light pollution isn't always very static. It sort of scrambles in the sky, you know, like ups and downs. Look at the red hydrogen down here, then look at the green oxygen, and then you can just barely start to see, after just 80 seconds, you can start to see these little lobes that are starting to show up here. And that's where the gravity, or the, I guess, the electromagnetism of the star is starting to light up this ejecta material along a straight like pole. So that this might be maybe the north pole of the star, and that might be the south pole. Oftentimes you can still see the star in the middle. Now that's 100% of the optics that we have, but let's zoom in with some of the what you might call the digital zoom we have. And I don't think we're going to be able to make out the central star. This must be a foreground star. Sometimes the central star is still visible in these planetary nebulae because, you know, it shrinks down, and maybe it's like a third of the size that it was before. And so it's still visible sometimes, but in this one I don't think it's going to be visible. Okay, so this is the little dumbbell. And what we want to do is average about 3 minutes max on each object. Two Rivers Observatory. Stan, good to have you aboard. How long have we been using Astroplanner? Well, which time, Stan? we used it about 2 years ago for 6 months, and we went on and tried some other things. Then we went back to it a year ago, got caught up on observations, and then we went and tried some other things, and now we're back on Astroplanner for the last week. So if you mean this time, just a week. But boy, I've already fallen back in love with it, and it's working great. And now, Stan, the goal is, let's stay in Astroplanner. Okay, so we could see the red H2 in the poles of this planetary nebula, and the green lobes starting to form after just 80 seconds.
Observation logged.
Okay, so next target without plate solving. Let's try it again. And let's go to the spiral cluster. And this is M34. So why did we switch back to Astroplanner? You might be interested in that, Stan. Oh my goodness, you were one of the beta testers. That's awesome. Let me explain some of the reasons we switched back to Astroplanner from things like Deep Sky Planner, the SkyX, Sky Tools. I mean, it feels like we tried them all. One of the things we liked, and right here is this open cluster. It's called the spiral cluster. And I guess you can see some of the spirals going on here. So we're going to go right away, could see the spirals.
Observation logged.
Okay, next we're headed to the Pleiades. What did we like about the what do we like about Astroplanner? Well, number one, what we found in these other programs, for instance, like Sky Tools, is that it just wanted to box us in to its way of observing. For instance, Sky Tools wouldn't even give us the altitude of things live when we were observing. It wanted us to use a column for optimum viewing time and be in some kind of automated mode. I know that works for a lot of people, but boy, it doesn't work for me. The second thing we didn't like about the Sky Tools particular tool is that it would it would drop off objects from our list if it thought, for instance, that, now let's see if we're going to get all of, we might need to see one, trying to see if we're getting all 7 of this. I don't know. Oh, here, 1, 2, 3, 4, barely. There's one of the stars. This is Pleiades, so 7 sisters. So I think we're going to be okay. Next time we'll have to plate solve. It would drop off objects that it would drop off objects that it thought we weren't going to be able to see. And it would do that because it would think, oh man, you're never going to be able to see through that light pollution. You're never going to be able to see through that moonlight. And it would just drop them off. And it was like, you know what I compare it to? It's like HAL. Oh, I'm sorry. Thanks. Appreciate that, Stu. Thanks for watching out for me. It was like HAL in the 2001 Space Odyssey. I'm sorry, Dave. I just can't do that. That's the way it was. And I finally just, I couldn't do it anymore. Now, the developer is now developing an EAA version. So we'll see if that's going to help. But we also like the fact that AstroPlanner lets us do extra fields. And SkyTools won't let you do extra fields, custom fields. So for instance, we can set up a field right here on the right-hand side. Maybe you can see down the side here. This is a custom field for the sequence we want to use to go through all these objects because he didn't put them in any kind of logical order. So we need an extra field for the sequence. And you know, I just love the fact that AstroPlanner is flexible enough to do that. What about SkyX? You know, it was okay, but we discovered a lot of bugs in it. I know that's going to be sad for the people that are long-term fans of SkyX, but in some of the workflows we were using, there were downright bugs. I mean, literally scores of times the program would crash, and we would do the black box thing where it would send the report to the developers, and we've asked them if they'd refund the money. And they're not refunding it yet because they say, you know, we don't do refunds, which I think is so ridiculous. They have like scores of crashes in their records, and they've shown me that they can see those crashes, and they're still not refunding the money. So I hope they have a change of heart because I don't think that's really doing very good business. The other thing was I maxed out the number of observations. I got to 500 and it maxed out. And I wrote the company and said, you're kidding me. Nobody's ever recorded more than 500 observations with your program and it's 20 years old? So what that means is nobody was using the observation recording, which is to me just odd. Anyway, this is Pleiades. What I wanted to draw your attention to is look how you can start to see some of the nebulosity around these corner stars. See if I can pull up some more. Yeah. See how you can see now. In this case, it's probably just dust. And you might wonder, well, is it some kind of ionization? And no, it's not, because look, it's almost bluish. Almost bluish dust, which tells you that it's just dust. It'll be green if it's oxygen. It'll be red if it's hydrogen. This is just bluish. And that pretty much means it's just dust. And a lot of times, for a long time, we thought this dust was kind of part of the cluster. But now with the latest observations from more powerful telescopes, we're seeing that the dust actually is sort of sitting still, and Pleiades M45 is traveling through it. It's a beautiful cluster, isn't it? This is the Seven Sisters, also the logo for Subaru, which is, Subaru is the Japanese name for Pleiades. Saw the space dust. And Merope and company reflecting off of these gorgeous 7 stars. Now you might be wondering, how do you get 7? Well, it's 1,
Observation logged.
2, 3, 4, 5, 6, 7. Just barely got it all in here, didn't we? Anyway, nice looking object. Let's go to the M42, the Great Orion Nebula. It's probably one of the most observed objects in the northern night sky, isn't it? It's so big and bright and beautiful. The reason it's so big and bright and beautiful is because it's so close. For tonight, might be a good idea not to show us the sleuth cam, because you do forget sometimes. Stu, I think you're right. Let's just stay on the screen, and you can see the scope in the lower right and the sky in the lower right. I think you're exactly right, Stu. So Stu, Stan, you use the Astro Planner along with Nina. We use Nina for focusing here as well. I wonder if we're going to have to plate solve this after all. Let's stop the live stacking, go back to the 3 seconds and the 400. And let's live stack this after all. I mean, plate solve this after all. It's so fast now. Yeah, it's 1.3 degrees off. So now we can say, as soon as the scope settles, see how it's still just jiggling a little bit from the plate solve. There we go. Now we can just do next target, prep for imaging only. And it just starts the live stacking for us. If you're new to the channel, live stacking is collecting one frame after another and putting it in the RAM, putting it in the memory of SharpCap. And then SharpCap averages out all the light sources and lets the grainy parts that are like the light pollution sort of filter out. Now Stu here on the stream is telling us about the Orion Nebula, also known as M42, and NGC 1976 is a diffuse nebula situated in the Milky Way, being south of Orion's belt in the constellation of Orion. So while that's forming up for a second, let's go over here. We'll hover here for a second and queue up Stellarium so it'll match up now. This is so fun the way it automatically syncs with Astroplanner, thanks to our great friend
M42 selected.
Pete on the Isle of Wight. And this is another reason I kind of like Astroplanner, because it works so well with Stellarium. And Stellarium works great for these quick views of where things are. We can just back off and say, okay, here's Orion. If you can find the 3 belt stars and go down toward Rigel, this would be the sword in Orion's belt. And you can look for that in the southwest. It's beginning to head toward the sunset, toward the horizon of the southwest. West-southwest. So I think Stellarium is a great tool for this kind of purpose. And I do like the atlas in Sky Tools. Very, very precise. Gives name for all these stars. But boy, Stellarium just gives us that quick and easy way to look at things. Isn't this a beautiful object? This has to be one of the most beautiful objects in the whole night sky, doesn't it? It's just so photographically amazing. And you can see this with your naked eye, with a pair of binoculars especially, but even with your naked eye, you can see there's something there. Probably with your naked eye, and perhaps even, I don't know, with binoculars, it's just maybe black and whitish. There's not this color. It does take a little bit of stacked frames before you start seeing this beautiful color. Now you can see this part right here. There are especially 4 stars. This part of the object is called the trapezium by many, and those 4 stars, they're what's lighting up the rest. Look at all this H2. This is part of a very large H2 region. Notice how M42 is right across from M43. This part always looks sort of like a giant vulture to me. Oh, oh, and this is the head, and there's his open mouth. These are the big wings. Oh, oh. Anyway, we'll get 2 objects for 1 here. We're going to get M42 and also M43. M43 is sometimes called Demaren's Nebula. Demaren's Nebula. Do you ever wonder who Demaren was? It is one of the brightest nebulae and is visible to the naked eye in the night sky with a apparent magnitude of 4.0, 1,300 light years away. Stu says this is only 1,300 light years away. No wonder it's so bright. That's not very far by galactic standards. It's one of the closest regions of massive star formation. Closest regions of massive star formation. M42 Nebula is estimated to be 24 light years across, so its apparent size from Earth is approximately 1 degree. Tiffany says it is really gorgeous. And then I'm going to add here, M43 is the head of the giant bird. Oh, oh. Now listen to this. Pete's made this so we can get both observations at once. Listen.
Observations for 2 objects logged.
I think that's just genius. Thank you, Pete. Okay, here we go. We're going to go, we're not going to do, just going to say prep for imaging only. Or set to exposure 3 seconds. That's what we're going to do. And then head to M78. Now we're kind of making good progress here, gang. M78 sets at 12:34 a.m., if you're curious, at least here in Louisville. So you see, we're already, what is it, 11 p.m. local time. So we're already an hour and a half ahead of when things set. Now the clouds got in the way of our first 3 objects. So no matter what happens, we missed 3 objects tonight. That's M77, M74, and M33 because of the clouds. So sad. But we knew we weren't going to get M30 anyway because the observatory has the building in the way with where our observatory is located. So you can never get M30 in a Messier Marathon here at Emerald Hill Skies, sadly. But it was the best location for the observatory. Good evening, Larry. No problem. We were late getting started. Stu says, do the bird noise again one more time before we go to the next one. Oh, oh, oh. Stu, you're funny. Joke John, I hope Pete uploads that quick observation script to AP. He is going to do that, Joke John. He just wanted to do some more like error checking with it. Stu says, I don't say this stuff. Wikipedia says it. But Stu, you're the one reporting it. Tiffany says, it really is gorgeous. Okay, so we are plate solved. Oh, we were only off 0.07 degrees. Now let's do the live stacking thing, because we're not seeing this. This is, we're going to have to next target without plate solving. Right. This is M78. Now if you've joined us late, or if you don't normally watch the channel, you might have noticed that this is moving along at a very fast clip. And the reason why is because tonight's a little bit different. We're doing a Messier Marathon. Messier Marathon was started, actually, the thing is, after Messier did his first 45 objects, 2 or 3 other people worked with him and sent him additional objects. And they were saying, well, if you're going to keep track of these, here are some others you might want to consider. So what he would do is with his buddy, what was his buddy's name? Like Pierre Messier, he and his buddy would confirm these, and then they would add them to the lists. And I think it went through like 3 different versions or something. And then brother Mr. Messier perished. But we've got his notes over in wherever he was observing, Paris and stuff, Oxford and Paris. We've got his notes. So some people have studied his notes, and they actually found additional objects that he cataloged, and he just never published them. So in the 60s or so, I forget, some researchers did him the favor, so to speak, of adding additional objects. By the time he got to the late 60s, the list had grown to 110. And now keep in mind that 110 does retain a couple of objects that are not truly what you might refer to as deep space objects. They are more like just mistakes. Like there's one that's a double star. We'll get to it later in the night. And I always think this is sort of a ghostly kind of nebula. M78, doesn't it kind of look like there are the 2 eyes of the ghost? I mean, anyway, this is M78, NGC 2068. And you notice after just 2 minutes, we can see all this nebulosity around it. Let's go over to Stellarium real quick. And again, now watch what happens when I hit Control 3, okay? Here it is. Control 3, 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010.
M78 selected.
So it took 10 seconds for that second script to load in Astroplanner and then execute in Stellarium. It's because Astroplanner can only keep one script in its head at once. Kind of like, you know, a person that's kind of like focuses on one thing at a time. It can't multitask. So it does take it a while. Oh my goodness, look at the name. The Friendly Ghost Nebula. I give you my word, I didn't know that was the name of this nebula. But I have seen it before, and it does always look like a ghost. Look at that. There it's 2 eyes. Now you can see this is part of a much larger pattern of nebulosity. Here you've got NGC 2067, and here is NGC 2071. But for some reason, the only thing Messier saw was this M78. Stu says it's the brightest diffuse reflection nebula of a group of nebulae. Oh, he just told you. That includes NGC 2064, 2067, and 2071. It's a reflection nebula in the constellation Orion discovered by Pierre Messier, so that would be his buddy, his assistant. About 1,350 light years distance, so it's probably part of the same group as the Orion Nebula. So that's pretty cool. Casper, the Friendly Ghost. We'll see if we can bump at the mids and pick up any of the rest of that nebulosity. And you can, even after just 4 minutes. See this nebulosity here starting to pick up? And that is NGC 2671 is starting to show up here after just 2 minutes. And look how 2000, what was that, Stu? 67 probably. 2067, yes. So 2067 is starting to show up. And I bet you're going to tell me this is 2064. Boy, that's beautiful there, isn't it? Look at all that red hydrogen. And look, there's some dark nebula here. Ooh, that's cool. All right, here we go with the observation. Now notice, we'll count again. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010, right there. So it's taken about 9 seconds maybe we could see partner nebulae here. But Casper, the friendly ghost, stood out.
Observation logged.
You just want to say some kind of ghostly sounds. Woo! I don't know what sound ghost makes. Anyway, that's 5 minutes. That's a beautiful little nebula. All right, here we go. We want to do next target. No, set exposure to 3 seconds. And off to the little beehive. So anyway, I got back into Astroplanner, and of course Pete hooked me up with these little scripts. And so it really started working well with Stellarium, and that made me happy. And then notice how I'm just really, I love the way this list works. When you do an observation, the item doesn't have to disappear, and I like that, because this way, look, we can see our progress. See all these gray boxes? This way it sort of checks it off and it lets you see your progress. And if it just makes it disappear, bam, it's gone and you can't really see what you've done so far. So I like that. I like it that you got all this data here. It tells you the real altitude right now at this minute. I like that. It's very cool. You can sort things. Anyway, this is a little beehive. NGC 2287. Now watch, if we haven't done the Control 3 macro, which is what we use for the sync with Stellarium script, now watch how quickly the observation will come up. I'm executing it right now. It's just instant. So if you don't go back and forth between those scripts, then as Pete had told me in advance, these come up just instantly. We could really see all the bees without having to place to live stack. MC, this is M41, sorry. Little beehive, it's M41. I'm a bit lost. You navigating with Stellarium or using it to add observations on Astroplanner? Dave, sorry, I should be more exact.
Observation logged.
Let's head to the butterfly. Here's the workflow. We're using Astroplanner to drive the scope. So Astroplanner is the headquarters of everything. And then we have SharpCap so that we can plate solve in the SharpCap, what Robin calls sharp solve. And then when we want extra detail, we look at Stellarium and we use a script that connects Stellarium and syncs it, it synchronizes it to whatever Astroplanner just commanded the scope to go look at. And Stellarium looks at it too, thanks to Pete. And then we can look at Stellarium and then go back to Astroplanner and make the observations. So really we're using Stellarium just as a reference tool to kind of get the big picture once in a while. Now this is M93, it's called the butterfly. See if you can find the butterfly wings. I think they're right here. Let me zoom in a little bit. Look here, I think is one wing, and it goes up like this. And then here I think is the other wing, and it goes around like this. And then this is the body of the butterfly. How about that? Control 9, instant observe script. Woohoo! Thanks, Pete. And you know what this did? It enabled us not to have to use the observation tab in Astroplanner, which has some kind of, for me, some kind of problem. There's a lot of latency. And I can type one letter at a time. But Pete made the script, and there's no latency at all. We could see the butterfly wings instantly. Beautiful cluster. Okay, so Stu's got the beehive information there. It's an open cluster constellation Canis Major, sometimes referred to as a little beehive, discovered by Giovanni Battista Odierna. Sounds Italian. Before 1654, it was perhaps known to Aristotle around 325 BC. Wow. We can see the beautiful wings. Okay.
Observation logged.
Now, here's some fun parts. I worked ahead of time, and I don't usually get to do this. So here we're going to salute actually to a star named Tycho 05409, etc. And this star has like a 25 number long address. Now, to be fair, let me just shoot straight. Stellarium couldn't tell me the name of the star. I had to open up Sky Tools because it has a more detailed atlas. So yes, I like referring to Sky Tools atlas when we need fine information, you know? Now what I did is plate solved in SharpCap. We were off about 0.2 of a degree, and SharpCap will get us oriented here. And M47 and M46, they're not visible to us yet, are they? They're open clusters. They should be. Oh, it's because we're not backed off. Let's go back. Yeah, here's M. What we're going to do is quickly plate solve, solve only. And then to get these straight, let's use deep sky image annotation. So this is M47 here at the bottom. And this is M46 at the top. So 46 is top. Everybody remember that? M47 at the bottom, 46 at the top. Now notice they just barely fit in our frame. So here's what I did. I found a little star right in the middle that would let us get two objects for one. How about that? And we have several like that. So here we go. We're going to go Control 9. M46 at the top of our field of view. M47 at the bottom. This Tycho star as a target worked great. These are gorgeous clusters. And we do have the
Observations for 3 objects logged.
Do we not have the distance here? I'm going to go other edit list columns because I thought there was a distance. I thought we could get the distance. No, I don't see the distance in AstroPlanner. Pressure's on, Stu. Oh, here it is. The current, no, that's angular. I'm not seeing the distance. So I don't think AstroPlanner has the distance. We're going to have to add these. Huh. So Stu, it's all up to you. Anyway, this beautiful cluster, and we didn't have to live stack, so we're on to M50. M50 sets at 128. So again, we're getting ahead of schedule, moving quickly like this. And this is a heart-shaped cluster. In fact, it's even known by that name, M50, the heart-shaped cluster, also known as NGC 2323. Now let's see if we can find this heart. I'm thinking, look at this. It looks like a Valentine. How about that? Are you seeing it? You seeing it, Tiffany? M46 is 5,000 light years away. M47 is about 1,600. Wow. So they're different distances. They just look side by side in our field of view. What do you got for M50, Stu? We're going to have to get all these distances and put them in a column manually, because I'm not seeing it. Anyway, this is definitely heart-shaped. Tiffany does see the heart-shaped. Looked like a Valentine, for sure. Tiffany loves it. Heart-shaped cluster is an open cluster of stars in the constellation Monoceros. It was recorded by G.D. Cassini before 1711 and independently discovered by Charles Messier in 1772. So what happened was
Observation logged.
Messier would see these and he'd say, okay, I don't have to go look at that one again because I'm going to record the fact that I was here. So really what this became a list of not comets. And isn't it kind of ironic that it ended up being probably, arguably, the most well-known catalog of objects, and certainly one of the first catalog of objects that astronomers could ever see, especially amateur astronomers. Now we're already zoomed in here, so let's go back out. This is M48, otherwise known as NGC 2548. So that's just a mistake. I mean, coincidence that they have both the 48 in them. M50 is 2,900 light years from Earth, has a core radius of 5.9 light years. Now, I would have to say that M48, nice open cluster. These always remind me of fireflies, a swarm of bees, Christmas lights, and Christmas lights.
Observation logged.
Now next we're off to the actual first object that Messier cataloged. By the way, Stu says that he found M48, oh, maybe M50. He found M50 while he was looking for Biela's comet. Stu says M48 is an open cluster of stars in the equatorial constellation of Hydra. Hail Hydra. That's from like a Captain America movie or something, isn't it? It's about 2,800 light years away, M48 is. Are we already at M1? Because you sure can't see it here, can you? Let's plate solve just in case. Look how fast that is. Oh, we were 0.4 degree off. When the telescope has to travel farther, it gives a chance to be a little bit farther off. I already see it. It's this very nondescript little blob there in the middle. Okay, so we're going to have to live stack this. So we're going to say prep for imaging only. This is M1. So this is the first object that Messier found. And it's the only one in the list of its kind. And what this is, not a planetary nebula, not an open cluster, not a globular cluster, and not a galaxy. This is a supernova remnant. And the star that exploded for this, I think exploded in 1054. We know that because there were some Chinese observers that were on their game. And as soon as it lit up, it showed up in the daytime sky, by the way, for like 3 weeks. It was bright in the daylight sky. So imagine seeing a star that was so bright that you could see it in the daytime. And then after the 3 weeks and it faded out of the daylight sky, it was the brightest star in the nighttime sky for a lot longer. And finally it faded out to be, you know, sort of equal with the rest of the stars, and then finally faded out and became this. And what this is a different kind of ejecta. And a planetary nebula is formed when the star is, now help me remember this, guys. See if I can get this right. I think if a star is about the size of our sun, right? Then when it runs out of fuel, it collapses down on itself, but it doesn't have enough energy and fuel, it doesn't have enough hydrogen to restart the hydrogen. So it becomes like just a white dwarf star, and it jettisons off its ejecta. That's a planetary nebula. But if it's big enough, which would be what? Somebody's going to remember this. How many volume of our suns? Like, is it 10 times the volume of our sun and bigger? If it's 10 times the volume of our sun and bigger, or whatever that equation is, then when it starts collapsing down, it does have enough hydrogen, and it relights, and it explodes. And in one big explosion, it sort of blows itself to smithereens. And all that stuff that's blowing up is this. So this is actually the carcass of the supernova. And now that we're seeing a little bit better view of it, we've been live stacking it for 2 minutes and 40 seconds, which is not very long by astrophoto standards, but by EAA, it permits us to already start seeing hydrogen. See all this H2? We know it's H2 with our eyes because we can see how pink it is. See how pink it is? Now maybe Stu will tell us how big this is. At the center of nebula lies the Crab pulsar, a neutron star 28 to 30 kilometers across. Think about that. That's like 14 miles. You know, you might drive that to go to your school or something. And it spins 30 times a second. And every time it spins around, like a washer with a tennis shoe in it, it sends a pulse toward us. That's crazy, isn't it? So all this stuff flailing out here is all of its carcass. Look at this. We're starting to see some outer, what would you call those? Like outer rings of this shock. So when we're looking at this this supernova carcass, we're able to look back in time to 1054 and see the beginnings of this explosion. And it's never stopped expanding ever since 1054. Isn't that wild? So about what? Just shy of 2,000 years ago. Stu says crab legs. You are so right. It does look like crab legs. That's just very cool, isn't it? Let's darken up the night sky just one little shade. And let's brighten up the red a little bit more. And then we'll take a screenshot of this. Because it's just cool. M1 on 5 minutes, 2024 03 0, 2. We'll put it here with our other okay, off we go. Oh wait, we got to do a observation. This is one of the coolest objects on the whole Messier list. Supernova remnant. Stu told us about the Crab pulsar. 17 to 19 miles across, Stu says. Spinning 30 times per second. Actually, 30.2, let's be exact, huh, Stu? Times per second. Ricky says, so, the Crab Nebula was making dinner one night, and I asked to have some. It said no.
Observation
I told
logged.
it no to be so I told it no to be. I told it not to be so shellfish. So Ricky's going to do some Messier comedy for us. Okay, off to the M35. It's an open cluster. Let's go. Oh, we're already there. Look at that. Bam. This has some really cool blue stars in it, doesn't it? Control 3. 1001, 1002, 3, 1004, 5, 1006, 1007, 1008, 1009, 1010. Bam.
M35 selected.
Look at that. We're also seeing NGC 2158 here. It's the shoe buckle cluster. Let's get a sense for where we are in the night sky. We're looking toward the west, almost due west, and looking about maybe halfway up. The shoe buckle cluster. Tell me this, guys. Why shoe buckle? M35, also known as NGC 2168, or the shoe buckle cluster, is a relatively close open cluster of stars in the west of Gemini. Larry says M21 is a pretty one. Oh, he means M35. M35 man. About 2,970 light years away. Tell you what, to think that Messier saw these from Paris with his telescope that was in the light pollution of Paris, shoe buckle, I'm not seeing it. 2970 light years away. Actually discovered by a guy named Jesse. It sounds like a sneeze.
Observation logged.
Off to M37. Man, I'm sure glad you guys were here. You know, you didn't have to come because I thought everybody would probably go to sleep or something, since we thought it was going to be cloudy. But instead you came. Is this it? Boy, it has a lot of little... Are you sure this is it? Yeah, there's, oh, we're still in M37, so we didn't slew. Okay, so get rid of the deep sky image annotation. Why didn't we slew? I must have hit M37 by accident. Okay, off to M9. I can see why I do, because you don't see the log. Oh, rats. M37 was a different cluster, wasn't it? Lots of little tiny blue stars. And then this
Observation logged.
This is the pinwheel cluster. Looks like a whirligig. Are you seeing it?
Observation logged.
I wish we could spin it around fast. It would really look like a whirligig. Off to the starfish cluster. M38. We're off to see the starfish. Kevin, welcome. We got started a little bit late. We missed the first three objects because of clouds. M77, M74, and M33. Oh, Stu says, you just started at 4:30 my time. Why would I be asleep? Tiffany, you are so kind. She says, so glad to be here and grateful that your sky cleared. Thanks, Doug. Thank you for being here, Tiffany. M36, 37, 38 jump from one to the next. I like open clusters, more variety than people give them credit. You are so right, Larry. This is called the starfish cluster. Anybody see the tentacles? There's one. Here's another. Here's another. Maybe here. I'm seeing it. By the way, looks like there's a little tiny cluster here too. Let's plate solve only. And it's NGC 1907. Okay, so the starfish cluster really looks like a starfish. Kevin came in on Casper. It really does look like a starfish. It was discovered by Giovanni Battista Odierna before 1654. This guy
Observation logged.
pretty good with his clusters. I remember you mentioned him before. All right, off we go to, I always want to say Principe. Do you think that's how they say it? M44. The beehive cluster it's called, M44. It's also known as NGC 2632. I'm just going to edit this because we have beehive cluster in there twice. So down here at the bottom, we can edit Astro Planner very easily as we go. Now, this was another thing I didn't like. About Sky Tools. No offense, Greg. You can't edit Sky Tools names. I guess he figured we would mess them up. So he doesn't let us edit it. So you can't add custom fields, and you can't edit names. You're just kind of out of luck. And he really frowns on it if you try to add a name. There is a way, and I did it a couple times, but boy, he made it clear he doesn't like it. He says that when you upload a list later, that your extra names upload, and when somebody downloads that list, it's like a virus, and your name starts circulating throughout all the users. And so I said, okay, I won't add extra names. And then I bolted to Astro Planner. Because here you can edit that, and you can tune up the little list of, like, look, manger's in there twice too. So I'm going to edit this manger out. See, it lets you. Good old Paul lets us have more power. It's not like 2001 Space Odyssey. What is this? I see it's like a little manger. Everybody see it? Away in M44. Look at that. It really does look like a manger. The manger jumps out at us. But now tell me, what does Praesepe mean? P-R-A...
Observation logged.
P-R-A-E-S-E-P-E. The Beehive Cluster, Stu says, also known as Praesepe, which is Latin for manger. Now we know. M44, NGC2632. Is that CR for colander, maybe? Or chromium? 189 is an open cluster in the constellation Cancer. It's one of the nearest open clusters to Earth. It contains around 1,000 stars. Kevin says that he says it Praesepe. Praesepe. And Larry says that's the way he says it too. So that's what we're going to do. Praesepe. Praesepe. Now to edit that observation, how would we do this, Pete? Let's see. Oh, I know. We'd have to go to the other tab. Let's go to the other tab and see if it slows us down. See if we get that latency. Praesepe, Latin for manger, pronounced Praesepe. Okay, not a lot of latency there yet. I still like the script better because it did have to redraw the screen and that did take a minute. So if you're really in a hurry, especially on a marathon like this, off we go to King Cobra M67. So, Astroplanner. Another thing that Astroplanner has that nobody else has. The SkyX won't let you do it. I asked Greg if he would consider programming it in SkyTools. He said, no way. Why would you have to associate objects? Paul, thank you for listening to your users, because associating these objects lets us go to one place for all the objects that are associated together. It's so simple. Astroplanner is the berries. I'm sorry I ever left, but the good thing is I came back. So there you go. King Cobra, M67, an open cluster. It's right here. Why do we call it King Cobra? No idea why it's King Cobra. Looks like 100 members.
Observation logged.
Okay, so what we're going to do on the next 3 objects is go to one star that's in between the 3 and hopefully get them all in one field of view. So see, because Astroplanner lets you associate objects, we can associate all 3 of these because they're in the same field of view. And then, if we look carefully, try to find a star. But, I got to tell you, in order to get that star's name, I had to go to SkyTools because it had the best atlas. And it was so easy because every single star in the whole world is named, just like when God names them. But in Stellarium, if you go to them, they just all say star, star, star. Let me show you what I mean. We'll go to Stellarium. We're really zoomed in here. But first we're going to start live stacking. And to do that, we're just going to say prep for imaging only. Did we plate solve? Let's plate solve first. Oh, we were off some. I think I see a few little smudges in there. So now we're going to say prep for imaging only. And we don't really need these names tonight. M95, M96, M105. All three objects, supposedly, in this one frame. Let's go to Stellarium. And we're going to aim on that star. And we're going to say Control 3. And it's going to count off its 10 seconds to load in the new script. And then it's going to take us right there to that star.
Object position selected.
Okay, now here's the thing. This star is so nondescript. Watch. It just says in Stellarium, star. That's all it says, star. And that's even a big one compared to these other tiny ones. In Sky Tools, should we open up and show you? No, because it's a little bit of a bunny trail, isn't it? Oh, let's go real quick. We're going to try to open up Sky Tools at the same time. I'm going to look for M95, M96, 105. It's opening kind of slowly. We got a lot going on. Okay, here we are. Okay, M95, right? Now hit A for Atlas. And look at the way all these stars are named. Now, I don't know if you can see the fine print, but look way down here in the status line. Every single star. It's just like with God. It's the same as with God. You know, that title is kind of in your way, isn't it? Let's get rid of that title. Every single star has a name. Bam. Bam. That's Tycho 00849-0402.1. Every single star has a name. And look, that's a little galaxy. LEDA 83336. I love Sky Tools 4's Atlas. So using it, I got a star. Now here's the thing. When you, I'm going to close this Atlas and go ahead and close Sky Tools so we don't have to run all that extra memory. When you look up those targets in Stellarium, it goes out to Simbad, which is a great big listing of all the objects in the sky, and it finds the coordinates for you and brings it into Stellarium so it can locate it here in this thing that it just calls star. So Stellarium is being good to us. It's locating the star for us. And that's how we did all these fields of view. Now let's see how we did. We're going to drop our black level to here. And we're going to run up our mids. Sure enough, when we do our plate solve only, it's going to help us do our deep sky image annotation, and it's going to show us M95's up here, M96 is here, and sure enough, M105 is here. Let's get rid of deep sky image annotation. So M105, I already forgot, and I already forgot. Which was which? Deep sky image annotation. This is 96 and that's 95. So it's 95, 96, 105. They're kind of in numerical order. 95, 96, 105. We get them all in one observation. That's fun, isn't it? Now here's what's really cool. Because we had to locate it in Stellarium, don't forget, we had to load that other script into Astroplanner's memory. But if I just talk for a minute and stall, when the observation comes up after 9 seconds, love this field of view work in advance with the Tycho star. All three objects at once. All three are galaxies. All three around 11 magnitude. What else can you tell us, Stu? M95, also NGC 3351, is a barred spiral. M95, barred spiral. That's up here. M96, also 3368, is an intermediate spiral galaxy, 31 million light years. M95 was 33 light years. M96 is 31 light years. I'm going to add this. M95 was 33 light years. And M105 is 36.6 light years. It's an elliptical. So that's pretty cool. You got three kinds of galaxies. Barred spiral. This is a intermediate spiral. And 105 is an elliptical. Now, elliptical galaxies, here's what I think the astronomy community did. We basically didn't know what kind of galaxy this is, except
Observations for 4 objects logged.
we knew it didn't have arms. It doesn't have these spiral arms. So we just needed a name to call it something. And it was not round, it was oval. So they called it elliptical, because they're not sure if it's spiral or not. Some people think that ellipticals are maybe spirals that have interacted with other spirals. And as the spirals got all jumbled up, it became this ellipse, you know? So it's fatter than a disk of a spiral. That's what some people believe. Spirals that interacted when they crossed each other's paths. I don't know. You can really see this intermediate spiral. That's a beautiful little galaxy, isn't it? Let's see if we can brighten it up a little bit more. Wow, that's cool, isn't it? Looks like something right off the Jetsons. Look at that bright core and those arms. Oh, it's been 7 minutes. We got to make trails. See if we can see the bar in this one. Oh my goodness, you can see the bar. This is not kid-friendly if we're going to have bars show up in this presentation. Look at that. Wow. TM96 group, also known as a Leo 1 group, is a group of galaxies in constellation Leo. This group contains between 8 and 24 galaxies. Wow. That's just so fun that you can see that bar so well. Papa Tech, the battle is raging. No, we're doing fine. We got started a little late, Papa Tech, because of cloudiness here in Louisville. But it's just 3 targets we missed because of cloudiness, and we love this target. Off we go to the Leo Triplet. This is another situation. Oops, we got to stop stacking. This is another situation when we're going to try to go to three objects at once. So anyway, Papa Tech, we are, does it tell us? Well, we're on 35, and we only missed 3. So not exactly 32, because our guide stars are in these lines. And we've had 3 different times we've used guide stars. So you got to subtract 5. So we're 30 objects in, so almost a third of the way. Boy, not seeing much here. Let's play solve. There might be one here and one here. We were very close. 0.02 degrees off. 0.02 of a degree. Is that settled? Yes. Next target without plate solving. This is M65 and M66. 2 members of the Leo Triplet. Papa Tech says, wish it wasn't cloudy here and windy. Even canceled the SpaceX Crew 8 launch. Another chance tomorrow night. Wow. Stu says, the Leo Triplet, aka the M66 group, is a small group of galaxies about 35 million light years away in the constellation Leo. This galaxy group consists of the spiral galaxies M65, M66, and NGC 3628. Oh my goodness, right there they are. You know what? We get on these killer scope lists, looking at these little tiny objects that are 2 arc seconds wide, and we forget how amazing these bigger targets can look, don't we, gang? Because we're out there trying to find those exotic 3 arc second wide things. That is just the coolest thing ever. You know, if you turn your head sideways, it kind of looks like this, what? Cartoon character. And the hamburger, which is the NGC 3628 object, the hamburger becomes the mouth. And M65 and M66 become the eyes, don't they? And this little bright star here is like a little freckle. Robin, if you're ever out there listening, man, you're a genius. How did you make this stuff solve so quickly? So again, NGC 3628, M65 is up here, and M66 is here. That's impressive. Let's do a... Now, to help you understand this field of view, to get context, that's just 84%. That's 75% of our field of view. This is a huge collection. This is Leo Triplet with 3 minutes. That's so unbelievable. are we able to see this in just 3 minutes? Look at this. This looks like something right off Star Wars. Doesn't it look like that's Lando Calrissian's hideout? And we're going in. We're going to land at Lando Calrissian's hideout here. Wow, look at all that. I guess that's a star forming region, right? Wow. Okay, that's 4 minutes. Long enough, Doug. Get your wits about you. Stu says, though my soul may set in darkness, it will rise in perfect light. I have loved the stars too truly to be fearful of the night. Wow, Stu, where did you get that? The name Sarah's Galaxy is thought to refer to poet Sarah Williams, most famous for the poem The Old Astronomer. NGC 3628, a.k.a. the Hamburg Galaxy, a.k.a. Sarah's Galaxy. Whoa! That is so cool! This hamburger galaxy. Is that it? No. That's not it, is it? Cancel. Oh, well done, Pete. I even got to cancel the observation. We don't have this object on here, of all things. So, how are we going to observe it? We're going to add it real quick. We're going to say plus NGC 3628. And then we're going to say, put this in slot 36. Right here is where we assign the slot number. And then we're going to say sort that column. Now we've got the third member of the Leo Triplet. We're going to go Control 9, and we're going to say the hamburger galaxy though my soul may set in darkness, it will rise in perfect light. I have loved the stars too truly to be fearful of the night. Sarah Williams, 1837 to 1868. Wow, so she only lived to be 31. Most famous for the poem, The Old Astronomer. This galaxy is nicknamed Sarah's Galaxy. Wow. That's just the coolest thing ever, Stu. I'm going to put here, contributed by Stu. Wow. Now some people
Observation logged.
Some people might wonder, why did Messier catalog 65 and 66 but missed NGC 3628? He didn't catalog it. And most people think it's because it's bigger, so the surface brightness is actually lower. But to us, it's an optical illusion that it looks more or less equal. But if you look at it carefully, it is fainter. And you can see how it got lost in the Paris skyline because he didn't have a Celestron light pollution filter. And that's the way it was. back in 1754. Okay, next object is another double. We're going to go to Tycho 0438, 25 other digits, in order to go observe M81 and M82. I can see what happened to Stu. Talking about the Hamburger galaxy made him hungry. Stu left his post. So I don't know. Who's going to step up? Kevin? Larry? Tiffany? Somebody's got to step up. M81 is Bode's galaxy. M82 is sometimes nicknamed the Cigar Galaxy. Larry says he can give it a shot. Thanks, Larry. Oh, they're right down here. I love it. So Bode's galaxy, let's start live stacking. Next target without plate solving, yeah. This is M81 and M82. You notice how when we go to a new object and it starts to build the first frame, you see a glimpse of the last object.
M81 selected.
And that's because it's the memory of that last object still in the memory of SharpCap. These are going to be beautiful objects. Let's look at them over in Stellarium real quick. So Cigar Galaxy, Bode's Galaxy, and if we're lucky, the Garland Galaxy. And again, that's because we tuned the frame on this star here. And hopefully that lets us see, sure enough, the Garland is here. So Bode's, Cigar, and Garland. And the Garland wasn't spotted by Messier. Bode's, Larry, can you tell us why it's called Bode's? I forget the story. It seems like Bode was an astronomer, and maybe he discovered this, right? No, because Messier discovered it. 70 million solar mass black hole. M81 Bode's has a 70 million solar mass black hole in the center. Discovered by German astronomer. Discovered by Bode, a German astronomer. It bodes well for his abilities. And then 1779, Messier. So Bode beat him by 5 years. 12/31, 1774. Instead of celebrating New Year's Eve, he was out at the telescope. His wife was inside getting drunk, saying, "Oh,
Observations for
Bo's out
3
there
objects
again."
logged.
She was getting drunk on New Year's Eve, and he was out at the telescope. It sure is a beautiful galaxy. And you can see why it's grand design, right? Look at these giant, giant arms spiraling out here. This is after just 3 minutes of integration. Let's pump up the mids a little more and see those arms a little better. Whoa. Now that black hole in the middle is 70 million solar masses, but it might not be that big. It might be only 1 kilometer wide in terms of physical size. But it's the mass that makes it eat up everything. Isn't that crazy? It could be the size of a basketball. That's just crazy. And then the cigar galaxy looks like it's on fire. Husband at the telescope, pretty common theme even then. Tiffany says, my kind of guy, woohoo! Oh, it's pronounced Bode. Johann Alert Bode. He was so alert, he noticed Bo's galaxy. Stu says, it's bodacious. That's awesome. This thing looks like it's on fire. And then Garland was not picked up by Messier. This is a beautiful little group, isn't it? Stu's advice not to do the scope cam solo was really good, because I do forget it sometimes. Sometimes a lot, actually. M81, M81, M82. 5 minutes on 2024-03-02. Okay, off we go. Next, we're headed to the Owl Nebula. Now, what I noticed about this object is if you slew to the Owl, then you're going to get M108. The Owl Nebula is M97. Now we're up to objects that are not going to set until, tomorrow morning or later. I think nothing else sets. Yeah. Now we might be far enough along that we can set it. Not quite. Here we are at Owl Nebula M40. The Owl Nebula, also known as Messier 97, M97, or NGC 3587, is a planetary nebula approximately 2,030 light years away in the constellation Ursa Major. So are we already set? I guess so. Because I don't see it yet. This is a dim target. Next target without plate solving. This is very faint. M97 and M108. Always like the owl. Fairly easy to find, but it's small. Well, this is really cool that, uh-oh, this is not good. Our phone, we better find a different way to run this. That's not going to work. Why is our phone not keeping up with charging? Wow. Let me see if I've got a phone charging cable here. Because it's going to low power mode and that takes away our scope cam. Yes, here's a phone charging cable. So let's find a USB connection right here. Let's go back and look at the stream. Are you guys still there? Can you still hear me? Are we still live? Can you still hear me? Oh, evidently so. So we plugged in the phone and everything went dead. What happened, Tiffany? Oh, so glad, Larry. Let's see. That was very unsettling, wasn't it? Plugged in the phone and the whole world went dead. Let's see, I need to get the scope cam back. How in the world do I do that? Scope cam. Huh, how about that? What a crazy deal. All right. This is the Owl Nebula down here. Now see the central star in this one? We are able to see the central star in this planetary nebula. And then look at that lobed, this is probably the north and south pole of the star. Then look at the lobed oxygen that we're witnessing here. Heavy on the oxygen, not as much hydrogen. And they take on different shapes, don't they? It looks like this might eventually develop some red, but after 4 minutes, not so much. So that's a planetary nebula. That's the one where the star was not big enough to make a supernova. Now up here, this is some kind of a spiral, right, that's interacting. It's either interacting with something or else those are star nurseries. What do you guys think? Do you have an opinion on that? I'm guessing it's interacting, right? This is M97, M108, 5 minutes, 2024-0302. Pretty cool. Stu says, 14th magnitude central star has passed the turning point in its evolution, condensing to a form of white dwarf. It has 55 to 60% of the solar mass, is 100 times solar luminosity, has a temperature of 123,000 Kelvin. Tiffany says it's a pretty one. It really is, isn't it? The nebula holds about 0.13 solar masses of matter, including hydrogen, helium, nitrogen, oxygen, and sulfur, all with a density of less than 100 particles per cubic centimeter. The eyes of the owl look like Joy's eyes. Wow, that's pretty cool, Tiffany. Well said. All right, on to the next object. We stayed here 6 minutes. So sorry, gang. But we did have our little hiccup with the phone that was going dead. Now it's charging. Set exposure to 3 seconds. And let's do an observation if we haven't done it yet. M97 Owl looked amazing, like Joy's eyes, Tiffany said. Stu said the 14th magnitude central star had condensed to a white dwarf. M108 is a spiral that looks like it's interacting with something.
Observations for 2 objects logged.
Thanks so much, Pete. Off we go to M109. This is a galaxy in Ursa Major. Let's edit this, can we? Sequence, edit. Let's edit the sequence that says next target without plate solving. And let's take out the prompt to enter target name. That's just wasting our time. Now that we took that out, though, now that I notice, we don't have a pause before plate solving starts. So maybe we'll cancel out of this anyway. Can I? Undo. Yeah. So maybe we'll just use that as a, let's just close this because we need to have a stop before it plate solves. Okay, so let's try it. Next target without plate solving. No. Prep for imaging only. And let's erase the object name. And let's just, oh, there has to be something. So we'll just put like a dash in there because we don't need to name that stuff because we're not using SharpCap to assign names to pictures. We're not taking pictures tonight from SharpCap. So that was kind of wasting our time to keep typing the title in there. Look at this. This is M109. It's right there in the middle. And it's already visible with one single 20-second frame. That's a beautiful star there, isn't it? I mean, if you like stars. We're going to be able to see the bar here. From the first 20 seconds, you can see the bar. Just copy and paste the chat, Doug. Cheat like I do. Yeah, but see, I'm using an iPad to read what you guys are doing here, so I can't go and copy from it. Messier 109, 3992, NGC 3992 of the vacuum cleaner galaxy is a barred spiral exhibiting a weak inner ring structure around the central bar, approximately 67.2 million light years away. Yeah, you can see that it does have an inner ring structure right around that bar. You're right. Barred spiral, 67.2 million light years away. Vacuum cleaner. Why would it be called that?
Observation logged.
It's very cool. Set exposure to 3 seconds. Oh, this is the double star deal. Winnicky 4, it's M40. Messier 109 was discovered by Pierre Messier, 1781. 2 years later, Charles Messier cataloged the object as an appended object to his publication. M109 can be seen southeast of the star Phecda. That's Gamma Ursa Majoris. Thanks, Stu, for helping me remember my Greek letters. I had 5 years of Greek, but that was in seminary like 1983, so it's too long ago. I remember some Greek letters, okay, but not all of them. That's crazy. Tiffany, I'm thinking Spaceballs, she says. Spaceballs. Stu, Stu needs some astronomer steroids, he says. Okay, so this is going to be this double star deal. And look, it's right there in the center. So please, somebody interpret for me, why in the world did Messier see these two stars and think that it was a deep, why did that confuse him? Did that just look like a comet when he was drunk one night? Stu, you're right. A lot of the objects were discovered by others and he just cataloged them. But, you know, although the list got his name, I think he would have acknowledged that they were others, maybe. Maybe. Anyway, we're going to say here, 2 stars, question mark, question mark, question mark, ha ha ha. He must have been drunk this night. Messier. How did this look like a comet? Okay, off we go to
Observation logged.
M106. Larry says, well, it might have been a comet that he misidentified. I guess so. You're saying there might have been a comet between these 2 stars. Larry, that's hilarious. 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 I get it. Come on in. Okay, I see our objects right there in the middle, but we'll plate solve anyway, just to be sure. M106. Okay, so 12:30. If you're tuning in late, this would be the time that we would normally stop our live stream. But tonight we're going to try to push through. So I don't know if we should take like a break once every 2 hours. Seems like that would be a nice thing to do for people, right? Next target without plate solving, right? Prep for imaging only. Oh, so it kept the dash in there. So maybe we'll do like a 5-minute break or a 3-minute break or something. Wow, that's a cool. Tell you what, we'll just let this cook for a minute, and we'll. How do we do this? Like that, I guess. We'll let this cook for a minute. And take like 4 or 5 minutes, something like that. Sound good? How do I do this with the mic? I guess I can go down here and go. Yeah, that's going to work. All right, we're going to do, Tiffany's getting some chocolate. Yeah, let's do like a 3 to 5 minute break in case you need to take a bio break. And we'll come back in 3 to 5 minutes. Okay, is everybody back? Let's see. How do I get the webcam back? Ah. Is that it? Yes. Now, did that bring it? Yes, that brought it back here. I thought I would share with you guys in 2022, I guess. Here we are, in 2021. In 2021, we did this with a bunch of other amateurs. Like, there were probably a dozen of us. And they're all listed here. You can see my name, Doug Lucas. And we're all listed there under Cloudy Nights Electronically-assisted Astronomy. Now that year, Cloudy Nights didn't like it that we used their name. So the next year we did it again. And we just called it the Electronically-assisted Astronomy Global Team. EAA Global Team. So we have even more people that year. And the way we would do these is we would divide up the list, and each guy would take like 10 objects. And it's because we didn't have this workflow very quick. So last year, Stu and I just did it together. And Stu was in Tauranga and I was here, and we observed together. We took about a 4-hour nap somewhere in the middle, and otherwise he was up with me the whole night. So what I'm telling you guys is, if you don't mind, I've put in the chat panel a website. Just go to emeraldhillskies.com/contact. emeraldhillskies.com/contact. And give me your name there. If you'll stay with me all night, then we'll submit your name and you will have done a Messier Marathon. How about that? Stu says, the math at the bottom nearly got me. Tricky one, that. It's with instead of a CAPTCHA, we use a math problem there. Eli, good to have you aboard from New York City. TL, too long, didn't read, Stu says. It's a lot of words, but that's the Messier Marathon list of results. And so you guys can see this is my, what would that be, 4th year to do it. And I'd really love it if you guys would be a part of this. Anyway, this is M106. Gorgeous. Lots of clouds and nebula. I guess nebula is the word for cloud.
Observation logged.
Off we go to, let's see, next. Set exposure to 3 seconds. Croxi Galaxy. It's object number 45. Hey, now we can see the entire list that's left. So over there on the right, this list, now we're seeing everything that we have yet to do. We're at 45. And there are 120 lines here because we have several target stars. There are only 110 objects in the Messier list, but we have about 10 target stars for some of these groups. Okay, so this is also a galaxy, right? 45, yeah, Croxi Galaxy. So we're going to stack this. Prep for imaging only. So that last object was Messier 106, and Stu says, also known as NGC 4258, is an intermediate spiral galaxy in the constellation Canis Venatici. It was discovered by Pierre Méchain in 1781. I think his assistant should get a lot of credit for these, huh? Eli, I'm not sure I can stick around for the whole marathon, but stick around as long as I can. Good deal, Eli. That's awesome. Wow, look at this. No wonder they call it the Croxi. Let's zoom in on this. It does look like an eye, doesn't it? Whoa. Haunting. Whoa, it's creeping me out. I just want to get out of the way of this thing. You know, during break, I found some yogurt. This is Oikos 000. It has 0 added sugars, 0 artificial sweeteners, 0 fat. So I don't really know if there's much in here. It's 0 everything. Anyway, is it going to gross you guys out to eat in front of you? I feel bad eating in front of you. Let's, there we go. While this is stacking, I'm just going to take the mic off for a minute so you don't hear me slurp the yogurt in. It's actually really good. I take back everything I was saying about 0 this and 0 that. Kevin found Japanese green tea ice cream. Kevin, with deep respect, that does not sound at all good. That sounds worse than my yogurt. This yogurt is really good. It's vanilla, of all things, but it's really delicious. Okay, I'm going to have to do commercials for them for sure. Messier 94, also known as Cat's Eye Galaxy and Crocodile Eye Galaxy and Croc's Eye Galaxy, is a spiral galaxy in the mid-northern constellation Canis Venatici. Tiffany, just so you know, Kevin, is after your ice cream. She's going to trade you her Nutella. Chow down, Doug. I cannot imagine green tea ice cream. Stu found mung bean ice cream in his local Chinese supermarket. This was discovered by Pierre Michin, 1781. Okay, let's do this observation here. Really did look like a croc's eye.
Observation logged.
Let's that's spooky. This is M94, and this is 5 minutes. And now we're going to go to Set exposure to 3 seconds. The Sunflower Galaxy, M63. Actually, Kevin is pretty interested in your Nutella, Tiff. He loves Nutella. I think you guys have some possibilities working out here between the green tea ice cream, Japanese green tea, and the Nutella. That's just really wild. Green tea. How can this be? M63. You know, so there are other lists that people have made, and honestly, some of the other lists make more sense, if I can say that. Like, maybe a guy has taken on doing a whole list of double stars, or maybe somebody else has done a whole list of, you know, dark nebulae. But this one is such a mixture of things. It's just wild. This is a beautiful galaxy, isn't it? You can see why it's Sunflower nickname, huh? Messier 63, also known as NGC 5055, or Sunflower Galaxy, is a spiral galaxy in the northern constellation of Canis Venatici with approximately 400 billion stars. 400 billion stars. I just want to go play some song from The Greatest Showman. Messier 1779. It's beautiful.
Observation logged.
Like I say, we've been doing these exotic things. We forget how beautiful these big objects really are, right? Because we're seeing these little tiny dot-sized galaxies because we've been doing these wild books and stuff. You know, our friend, Steve O'Meara, has a great book on all these Messier objects, and he must have had trouble thinking of a good title for it, but it's a great book. I mean, he writes lots of cool stories about all of them. I wish we could read it all. We just don't have time tonight to do this, but it is pretty cool. So I was going to tell you a while ago, I never did finish the story. We think that the Messier Marathon idea started with 3 different people doing this as a marathon. Started with 3 different people at once, independently. Next target without plates. Prep for imaging only. So Don Machholz, 1978, he realized in the 1960s that all the Messier objects were on one side of the celestial sphere. And so if you just could pick a day when the sun was traveling through the other side of the celestial sphere, so to speak, because of the movement of the Earth, in other words, with the dark sky toward the night sky end of the view of our celestial sphere and the sun on the other side. I'm not saying this very clearly, but he noticed they were all batched together there, and he wrote an article about it. But he didn't really write the article to 1978. He realized it in the 1960s. But in 1978, he wrote an article about it in the San Jose Astronomical Association newsletter and asked people to follow this kind of order with him. And when he got the 1979 Sky and Telescope, another guy was proposing it. And that guy lived in Pennsylvania and was completely independent of Don Machholz. That guy's name was Walter Scott Houston. And then, come to find out, Walter Scott Houston talked about Tom Hoffelter and Ed Flynn and Tom Ryland doing this in 1977. So people saw Walter Scott Houston's article, and several tried it that year and wrote Walter Scott Houston. Then somebody wrote from Spain to say Houston had stolen the idea, because there's this guy in Spain that had done it 11 years earlier. And the guy in Spain, they put him in a footnote. Wouldn't you feel bad if you just invented this idea of doing a Messier Marathon and then you only get put in somebody's footnote? I'm trying to look up his name, but I can't even find the footnotes. Where are the footnotes in this book? Must be at the end of the chapter, because they're not in the back. My goodness. Why did the guy from... Here they are. That guy's name that went to the footnote, the guy from Spain didn't even make it in the footnote. That's sad. Someone from Spain wrote to say that Houston had stolen the idea. They don't even say who he was. So if you're the guy from Spain and you're watching this, we are really sorry and we wish you'd tell us your name. But anyway, all three of these people somehow converged and came up with this plan. And so that was 1978-79. So somebody thinks that Don Machholz might have done it more than anybody else. He did it a lot. Anyway, he wrote this book about it, and in his book, he tells you, oh my goodness, look at this. This is M51. This is the Whirlpool galaxy, isn't it? Wow! We've been forever since we observed this. That is so cool, isn't it? So what this is, obviously, I mean, you already know this, is two galaxies interacting. I think, technically speaking, they have different names. Like this is M51 and this is like M51A. I've often wondered, doesn't this look like a lizard's tongue? And he's found a fly out here. So I would like to call this the lizard's tongue galaxy. Do you think we can make that stick? Now, I'm like Don Machholz and company. I've never heard anybody else call it that, but I'm sure somebody's going to write me from Spain and say, yo estoy llamando esta galaxia como what's the word for tongue? I forget in Spanish. Anyway, looks like a lizard has captured a fly, otherwise known as the Whirlpool Galaxy. Tiffany says it makes sense. It's interacting. And notice how the interaction
Observation logged.
has spread out this arm. So it's already had a big impact on the galaxy. Let's do a quick little... This is... M51 after 4 minutes. That is just so cool, man. Lingua. Thank you so much, Tiffany. Man, look at all these new stars. These are all brand new. Boy, I hate to leave this one. This is beautiful. But miles to go before we sleep. So let's go set exposure to 3 seconds. And let's head to M101, which is a beautiful galaxy called the Pinwheel Galaxy. NGC 5457. M101. Are we already there? That didn't take long. What? I think M101 Stu says it was probably the first night of March 23rd through 24th. It was probably first in the night of March 23rd, 24th, 1985, that Jerry Ratley from Dugas, Arizona completed the list and hunted down all 110 Messier objects in one night. So there you go. Kevin can see the lizard effect of M51. Isn't this gorgeous? Now, if I remember right, M101 has been the scene of a lot of supernovas, right? So I think it sometimes has been called like a starburst kind of galaxy because you get these supernovas that are bursting there. We have a lot of objects left to go, gang. Well, that's just 60 seconds, but isn't this a beautiful galaxy? This is gorgeous. Wow. The Pinwheel Galaxy, also known as Messier 101 or M101 or NGC 5457, is a face-on spiral galaxy 21 million light years from Earth in the constellation Ursa Major. So you guys know if it's like we're above it and looking down at it, it's called face-on. We can see the full face of it. And if we're at the side, looking at the edge of the disk, it's called edge-on. 21 million light years from Earth. Boy, I love this new observing script. Oh my goodness, it's so nice. 6 internal novae, have been recorded, Stu says. According to Stu, Stu's research. Stu, you're just like the walking encyclopedia.
Observation logged.
Look at this. Look at this arm way out here. And look at this extra arm out here. Wow. See how with EAA, you can see more and more material appear almost like magic. Because why? Well, because we're stacking one frame on top of the other. And when that happens, remember how this works. SharpCap does this magic. It erases out any of the tingly, shimmery night sky, like light pollution. It erases all that out, like with a pencil eraser, making it darker and darker. And then simultaneously, it brightens all of the star material that's, of course, it's stayed exactly the same in one place, and it's been consistent. So it really is a cool invention that Robin Glover and others have done with live stacking. Did I say plate solving? I meant to say live stacking. This is Butamus. Four minutes. Wonder what that noise is I hear outside. Not a cloud in the sky. Look at that. See the Big Dipper right in the middle? Not a cloud in the sky. It almost sounds like rain out there. Must be maybe dew dripping off the roof or something. Okay. Spindle Galaxy. Huh. M102. Why does it say in the notes of this object, duplicate of 101? What? Why would it say that? Oh, because maybe pinwheel is called spindle sometimes? No. Wonder why it says duplicate of 101. Kevin says, I know several people who think it's not a Messier Marathon unless you do it all without electronic help. Party poopers, Kevin says. Yeah. Stu says, bet they just don't have access and are jealous. You know, I think they ought to, you know, our good friend who volunteers to track all this, he's a German guy. He maintains the SEDS site. I think it's not a bad idea to qualify the marathon by how the person did it. I don't think that's wrong, because I admit we are really getting off well here. What's the temperature out there nowadays? It's not bad, 43.9, 43.7. It's not so cold tonight, but still 43 would be chilly, wouldn't it, after a while, don't you think? You see why they call this the spindle galaxy, because it's edge on, and this particular thing looks apparently like some kind of a thing called a spindle in making, what is that, knitting or some kind of textile. So I wouldn't mind it if they would say, okay, so this group used a go-to telescope and they used EAA and they worked as a group over live stream. I mean, you know, I wouldn't mind if they do that. But, you know, the guy who, I think his name is Hartmuth, the guy who maintains the SEDS page, SEDS, that I showed you a while ago, Hartmuth, I think is his name, something like that, German guy. He's nice, but he's just doing it as a labor of love. You don't pay anything. But he just puts whatever, you know, you tell him and trusts you with the honor system. I do think that a person that does it without a go-to scope and without EAA, so they're out there in the dark all night, I think that's a special talent as well. But I think doing it this way is a special talent as well, but that's a different kind of talent. It means you got to use star hopping and look at maps, you know, and do this with paper. And most people still use maps. They just use paper maps instead of electronic maps. Okay, so let's bounce to the, oh wait, it really does look like a spindle. Edge on.
Observation logged.
M53 is the next target. And this is number 50 out of 120 lines. So we're making progress, gang. Making progress. We're right now at objects which roughly sink below the western horizon at 909. So we're making good progress. Also called the Spindle Galaxy or Caldwell 53, is a field lenticular galaxy in the constellation Sextans. The galaxy was discovered by William Herschel on February 22nd, 1787. How about that? So he was a contemporary with, are we plate solving? I mean, live stacking yet? No, we're not, are we? Prep for imaging. I thought we were live stacking. Maybe it's because we went to M53. Oh, I think, Stu, I think you thought I said M83. But what I said was M53, M53. Oh, yeah, that's what you said. This. Did I? Are we at M53? Oh, it's a globular cluster. I don't see it. Do you guys? Are we where we're supposed to be? Let's do this. Here it is in the middle. It's a very loose globular cluster. Yeah. Oh, wait. NGC 5053. Is that M53, 5053? Is M53 one of these even? What in the world? I think this is a mistake. Let's stop. Let's go back to 3 seconds again. And let's make sure we've slewed to the correct target. Is this M53? Why is it not going anywhere? Oh, it says right here, last slewed to M53. Let's call up Stellarium. In the meantime, let's go ahead and start live stacking again.
M53 selected.
It says we're right on it. M53 or NGC 5024. I just coughed, Tiffany. You thought I sneezed. We're going to try this again with the deep sky image annotation. Why does that not say M53? It says NGC 5053. Let's go back to Stellarium and let's do a control search for NGC 5053. It's in a completely different place. What? Oh, look, here's 5053 down here. And there's 53. According to this is M5053 in the middle. We're zoomed all the way out. But Stellarium says our RASA is looking at M53. Tiffany says, gotta bless coughs too these days. Do you think look at NGC 5053. It has a giant equilateral triangle beside it with stars that are magnitude 7. This has, oh look, here are those 3 stars. There's one right beside it. This is the wrong coordinates for M53. So that means Astro Planner sent us to the wrong place. So let's do this. Let's add an object. And let's add NGC 5053. Let's make it object number 50. And then sort. And let's stop live stacking first. Let's slew to 5053. Did I do that wrong? I wanted to slew to 5024, didn't I? But that's already added. I don't think it's going to let us add that again. I think it's going to say, that's already in there, you dope. You see, 5024. Oh, it did let us add it. Let's put that in 50. Here are those nice big, this nice big triangle again. What do you guys make of this? Do we have a problem? This is wasting our time. M53. M5024. This should be it. Oh, maybe I see it in the middle now. Prep for imaging only. Yes, Corin. Good to have you here, man. Larry says, curious. It is curious. It appeared, oh my goodness, this is beautiful. So this is not the object we were seeing a while ago. So for some reason, and Pete, if you're watching this, for some reason when we added M53, it put NGC 5024 as the secondary, but the coordinates look wrong. NGC 5024, the right extension is 131255.25. NGC 5024, no, the coordinates are the same. But 5053's coordinates are different. So I don't know how to explain this. For some reason, where we were a while ago, that's where it took us when we said take us to M53. And even the slew said, you're at M53. But Sharpcraft Sharp Cap's plate solving was showing us 5053. Anyway, this is the globular cluster we wanted to see. So I think I'll make the observation here since it looks like it's the very same place. So now I'm going to delete this from the list. And make the observation here. It's got a greenish tinge, doesn't it? Definitely got a greenish tinge. Definite greenish tinge. Curious, when we first slewed here, Astro Planner said it had slewed us to M53, but we were looking at NGC 5053.
Observation logged.
So let's also delete NGC 5053 and Stu says, okay, Doug, we've seen it. Take it off and let's move on. I like it. Oh, Stu, you're right. Not green in the photos. Maybe check your levels. You're right. It could have been a color balance issue. Or maybe the photos you're looking at are black and white, Stu. Did you ever think of that? This is Black Eye Galaxy M64, otherwise known as Sleeping Beauty. I have another book here. This Messier Marathon book is written by a guy named Harvard Pennington. And this guy seems to be a colorful guy. There's a picture of him here. Can you make him out? He looks like a pretty colorful guy, doesn't he? Look at the hat and the shades. This is apparently at a star party. That's like a place where a bunch of people get together to look at the stars. Messier 64, Stu says, is a relatively isolated spiral galaxy 17 million light years away in the constellation Coma Berenices. Now you can see right away why we call this the Black Eye Galaxy. It's 17 million light years away. A dark band of absorbing dust partially obscures the lower part of the inner galaxy, causing this black eye effect. Evil eye, Sleeping Beauty.
Observation logged.
It's pretty cool. 2 minutes. Man. How can EAA be this cool to give you that image after 2 minutes? Wow. Look how wide it is. 10.3 arc minutes wide. Man, it's very cool. The interstellar medium of Messier 64 consists of 2 counter-rotating disks that are approximately equal in mass. Counter-rotating, I wonder why. Next we have a globular cluster, M3. Boy, our phone hasn't charged much. I mean, I think it might be off the emergency list, but not by much. It's a small globular. I guess it gets bigger when you plate solve. M3. What you got, Stu?
Observation logged.
Let's head over to M98. M98's a galaxy in Coma Berenices. Boy, sometimes when you first look at these, you wonder will there really be a galaxy that'll show up? It's just because we have these little 3-second high gain, 400 gain thing. And there it is. After a 20-second time exposure, there it is. Edge on spiral. Bright core. This is M98, NGC 4192. I know. Stu's saying 20 seconds? I want it now. Tiffany says, voila! Bright core, tiny core.
Observation logged.
Really cool. Intermediate spiral, 44 million light years away. When we're doing live stacking, Stan, the gain is on 100. That's like the sweet spot for this 2600. When we go back to this setting where we're like looking for something, we put it at 400 and we use real quick takes just because we're trying to get there fast. Let's go to M99 and M100. And what we do in this case, has anyone tried that little 5-inch RASA? No, I haven't. Stu says a spiral galaxy displays mixed barred and non-barred features with intermediate to tightly woven arms and no ring. It is highly inclined to the line of sight at an angle of 74 degrees. This is another case where we have two objects that we're trying to get in the same frame field of view. And they are M99 and M100. So what we did is we found a star in the middle, and in this case it was Hipparchus 60198. So in other words, it's just a random, nondescript star, but it happened to be positioned well so that if you moved to center on that star, you could capture both objects. And I've noticed in the previous Messier Marathons that I've done, I'll look at M99 and then I'll slew to M100 and live stack again. So this time we're saving the slewing time and the live stacking time. This image has several different interesting targets in it because it's in the Virgo cluster, as you can see. So this is M100 and this is M99. So for tonight, those are the two that are most important. But look at all these other galaxies because it's the Virgo cluster of galaxies. Crazy, huh? So 99 and 100. These are really loose arms up here. It looks a little bit like our friend the lizard, like it's interacting with something. And then M100, look, it's also loose. Loosely wound, in other words. See how wide these spirals are? So I think both of these have interacted with other objects. And so you see two objects here close. Stu says, Messier 99, also known as NGC 4254 or St. Catherine's Wheel, is a grand design spiral in the northern constellation Coma Berenices, approximately 49 million light years away. So M99, St. Catherine's Wheel. Interesting. I bet there's a story there. 49 million light years away. M100, also known as NGC 4321 or the Mirror Galaxy. 55 million light years. Both have loosely wound arms as if they've interacted with another galaxy like M51. So there we get
observations for 3 objects logged.
There we get, 2 for the price of 1. Now let's go to M85. Stu says 4 supernovae observed in M99 and 10 in M100. I think those supernovae are more likely to occur in galaxies that have interacted. I think that sort of sets the galaxy on fire, so to speak. This is M85. So I wonder what we'll do if our wireless mic runs out, because I use a little wireless mic. We'll have to switch like we did that one night to the webcam mic. So if the mic dies, you guys tell me that's what it will have meant, is that the batteries have died, because I don't think they're good for, I don't think one mic can last that long. We'll be about, Lord willing, if we can pull this off. Well, now wait, I can recharge it while we take our nap. So that should work out, hopefully. This is interesting. M85. So I'm guessing M85 is the bigger one. Yes. It's a twin with NGC 4394, but Messier didn't see that. So this is M85. Now I wonder if this star, that's probably just a foreground star. It's just between us. Is this an elliptical, Stu? Lenticular or elliptical in the Coma Berenices, 60 million light years away, 125,000 light years across. Very interesting. Lenticular is just really another name for elliptical. 125K light years across. 60 million light years distant.
Observation logged.
Pretty amazing that Messier was able to make these out with his homemade telescope in 1754, of all things. Okay, now here we'll try to get 3 for 1. This is going to be M84, M86, and M87. And this is part of Markarian's chain. So you guys are all familiar, I think, with that. It's a whole trail of objects. You might have wondered, yeah, Stu says there are 17 Messier objects in this one patch. Now, they don't all fit in the field of view of our RASA, but nevertheless, you're right, Stu, 17 Messier objects close by. Wow. 20 seconds is all it took. Look at all of them. Can you spot the galaxies? So here, here, and there are two galaxies here, two galaxies here, here, two galaxies here, one over here. And then look at these two edge-ons. Oh my goodness, look at all that. So M86 is this big circle here. M84 Anybody see it? Ah, here. M84 is here in the crosshairs, and M86 is here. And so 84, 86, and then we're looking for 87. Anybody see it? Wow, Carlo, good to see you on board from Tuscany, Italy. Carlo, we're looking for M87 here. It's like playing with a High Life magazine in a dentist's office years ago. Where in the world is Carmen Sandiego M87? M84, M86. Let's go ahead and you think it's right here? M84, M86. $747. Carlo, good to have you aboard.
NGC 4435 selected.
M84, M86, M87. Ah. It looks like it's not in this field of view after all. So it would have needed to be like that. M84, M86. So maybe down here somewhere, right off the frame. M87. 4486b. So it's right off of our field of view here. 2 degrees wide, Eli, and about 1 degree high. It's 2 degrees and a fraction. I have it written down here somewhere. 2 degrees 10 minutes by 1 degree 27 minutes. 2 degree 10 minutes by 1 degree 27 minutes. So what are we going to say about these two? M86 is elliptical. M87 supergiant elliptical. M86, M87 supergiant elliptical. Several trillion stars. Wow. One of the largest and most massive galaxies in the universe.
Observations for 4 objects logged.
M87. So this is what was off the field of view. We were seeing M87b here, so we were just off the field of view. So M87 is going to be in the center of the screen here. Oh yeah, M87 is that plasma thing, relativistic jet, one of the brightest radio sources in the sky and a popular target for both amateur and professional astronomers. See how long it takes for us to be able to make out the relativistic jet. It's 20 seconds so far. I think I already see it. I think it's going to be right here. There's 40. Let's darken up the area around it. See that little spur? See that little spur off the top side? So far there's still a lot of confetti, grain, noise. Can you make out that little spur? I'm going to go ahead and disassociate M87 and do a separate observation on it. We could make out the relativistic jet after just one single 20-second exposure, which is crazy. It extends 4,900 light years, traveling at light speed. M87 is one of the most powerful radio sources in the sky. Stu says Hubble showed us a big blue laser beam.
Observation logged.
Stu says he's heard of a new measurement. A supermassive black hole's energy is measured in supernovas per second. See that spur, that relativistic jet? Isn't that cool? It's almost harder to see because when you move the mids up like that, it brightens up the whole object, doesn't it? It almost helps to have the star, the galaxy itself, be a little bit down. So there's 3 minutes, and you can see that jet really well. Fascinating, huh? Okay, try to get 4 targets in one here. But obviously I had not checked these guide stars. This is all just done with Stellarium. So we didn't quite have M87 on the field of view. Yep, 11 o'clock, so it was right. We were seeing it. Excuse me. I hope I got this field of view better, but I'm not seeing anything in anything at all yet in this image. Oh, there we go. Oh, that was the last one, wasn't it? I know. Stu says, don't start yawning already, Doug. 2 a.m. here. I don't know where these objects are here. It's supposed to be 4 of them here. Live stacking. Oh, that's... So M90 is here. M89 is here. So 89, 90. '91. I think we missed 88. 89, 90, 91. 89, 90, 91. So this is 89, this is 90, and 91. These really don't stand out much to
M88
us.
selected.
How did Messier see these? The red triangles mean that the moon is going to be in the way, Eli. Means that the moon is going to blot them out. Actually, it really just means the moon is going to be within 20 degrees, but that, to a visual astronomer, that would usually mean the moon is going to blot them out. And maybe we can do a little bit with EAA. You can see some cloudiness around that. But you have to give it to Charles Messier, right? And what did he see here? How did he do this? That's just a fat star. Same with this one. How in the world did Messier ever tag that? M88. '90, '91, '89, '90, '91, and then up and to the left. Should be over here, but I think it's off of our field of view. Boy, they look like minor galaxies to me. How about you guys? 89 is a nearly perfect spherical elliptical in the constellation Virgo. 90, intermediate spiral, exhibiting a weak inner ring, 60 million light years away. Seems like you had a better setup than we do. Yeah, you're right. You're right, Dave. It is amazing. I mean, we can see that they're galaxies, but it wouldn't have stood out to us using a live telescope with no stacking. So let's just go. See, that was '90, '91, no, '89, '90, '91, but not '88. obliquely spherical, elliptical, M90, intermediate spiral, weak inner ring, 91, barred spiral, 63 million light years away, faintest object in the Messier catalog, 10.2 mag. I'm going to add right here under
Observations for 4 objects logged.
Let's change 91 to 65. Change 88 to 66. And get rid of this pointer star, because it didn't make the field of view. Okay, so here's 88. Kind of a romantic looking galaxy, isn't it? Reminds me of that sunflower galaxy we saw a while ago. Stu's reminding us to click like if you like this kind of thing. It helps other people find the stream. The scream. Thanks, Stu. Reminded me of the sunflower galaxy. Flocculent or flock, whatever that word is. Soft like cotton candy.
Observation logged.
All right, let's head to M58. You see here now we're at object 67 in the list. Messier died 50 years before the light bulb. That's crazy. So what you see on this list now, this is it. This is our last, this is our challenge. This is our quest. M58. We've got the rise time on here as well, and like for instance this object, which is labeled number 79, and we're on line 67. This object number 79, it's just now rising, 2:09 a.m., just now rising. This is a tiny galaxy too, look at this. This is M58. Of course, you know, he had a lot of people helping him, and some of them might have been in dark skies. Messier 58 is an intermediate barred spiral with a weak inner ring about 68 million light years from Earth.
Observation logged.
Excuse me. Let's look up here and see when the moon, so the moon just has started rising. Up here at the top, there's a little graph, and this little object that you see rising here is the moon. And it's at 53% tonight. Larry's betting that Paris itself is Bortle 2 because 1800. Good point. No light bulbs. So lots less light pollution. I yawned again. All right, 2-for-1 special, M59 and M60. These are both galaxies as well. This is a whole stretch of galaxies, huh? M58 is one of the brightest galaxies in the Virgo Cluster. It was arguably, though unknown at that time, the farthest known astronomical object until the release of the new General Catalog. Walter Sands' moon is currently occulting Antares. Could be a good object if you have a moon filter. You know, you're right, Walter. We just did a thing the other night about the moon. The thing is, we're focused on the Messier list tonight, so we better stick to our focus here, or we won't get done. And I don't have a moon filter. By the way, it's good to have you aboard, Walter. The way I do this filter is I just leave it. I leave the one filter that we have on there. It's a Celestron light pollution filter for the RASA 11, and we just leave it in place the whole time. We never take it out. Oh, these are a little brighter. M59 and M60. It's 59 on top. So this is M59. Pretty tiny. 5 arc minutes. This is 60. M59, also known as NGC 4621 elliptical. M60, NGC 4649, also elliptical. 59 light years, or 57 light years away, 57 million light years away. Carlo, thanks for spending some time with us. Looks like a beautiful refractor or something you have there in the back. Yes, still have the Octopi-Astro, Ricky. Haven't touched it. So,
observations for 2 objects logged.
So 59 and 60 here. You know, Ricky, since we did the Octopi-Astro, There's a new adapter. Oh, those are called ARP116 together. Oh, M60 with 4647 form ARP116. Since we did the Octopi-Astro, there have been several new camera adapters that have come out. One of them is something or other light cage, and it looks very interesting. But boy, those are expensive, aren't they? I was so blessed by that guy who invented the Octopi-Astro. He asked me to review it for him. I'm just amazed that he sent me the review unit for the RASA 8. And I felt bad because about 6 months later, I sold the 8 and got the 11. So I wrote him and said, have you thought about doing one for the 11? And he said, I'm just now doing it. And he sent me that one too. And I got to review both of them. And by God's grace, we didn't have to pay for either one of them. This is M49, right here in the middle. Looks like an elliptical, Stu.
Observation logged.
So we were very blessed to be able to try that out. This next one is M61, the swelling spiral. M61. And they were very good quality. They are very good quality, as you can tell, because I've just never moved it. I mean, I put it on and set it up. It took me probably 3 nights to get it within a range that was acceptable. Sync failed. Target exceeds the limit. How is that possible? Let's go back and check our tracking still on. Oh, I guess it's trying to go back too far the wrong way, isn't it? So strange. See, it's trying to bend over backwards too much. Crazy. So how do we fix that? I guess we'll go to another target temporarily. Strange. So I wonder why I couldn't sort that out. Boy, the moon is starting to wreak havoc with that sky over there, isn't it? See how you can see the moon coming up over there to the right. So now we've shifted peer east. This is M104, the sombrero. Ricky says, I keep looking into one, but I take my camera off and go into a dark site. Didn't know if it would screw back on pretty accurately to keep the tilt corrected. See, that's the hard part. I think every time you unscrew it, you have to start all over again when you screw it back in, because no, it doesn't keep its tuning. Walter says, Antares will emerge from the dark limb of the moon at 2:48 your local time, just FYI. Boy, Walter, I wish we could do that, but I just feel like with a Messier Marathon going on, we probably should stick to our Messier Marathon here. So there's a sombrero right in the middle. You think we're getting some fog? Look at the sky cam. See how we've lost the sky? I think we're getting some fog rolling in, sadly. Look at that. That should be, we should see lots more stars than 4 stars, 5 if you count this one. Yeah, Dave says, looks cloudy. Yeah, Stu's saying, let's stay focused on the Messier Marathon. But I would love to do that another time, Walter. I've never done those occultations much. That is the worst view of the Sombrero Galaxy I've ever seen. Look at that. Last 7 frames haven't been stacked because they can't even align them. So our RASA is still seeing 10 stars. But the SkyCam Palmer, hopefully just haze from how the moon is positioned. Could be. I wonder if you guys will still be able to hear me if I walk out the front door. I'm going to try. Just going to See, I've got my keys. I don't have my phone with me because if I take the phone, it'll take away the sky cam. But I do have my keys to the building here, so I'm not going to lock myself out of the building. So I'm just going to walk out the front door and take a look, because it looks like a lot of fog. Yeah, just as I feared. Absolutely covered. Guys, that fog is so thick. That sound I was hearing a while ago is the drenching of the fog dripping down the gutters. Remember I said, how can that be? That sounds like rain. The entire sky is just filled with so much drenching moisture that the gutters are dripping the moisture that's dripping down the roof. Rats. Look at that. Let's look at our dew point. 43.7. What is this thing? It's hard to read, isn't it? Oh, I think it says 99% humidity. Yeah. Let me show you. I'm reading this little applet I have with the Pegasus Astro power box. This little indicator here says it's 43.9 degrees temperature. This is the humidity. It's 99% humidity. And the dew point is 43.7. The dew outputs are automatic. They adjust themselves automatically, and look how high they are to try to keep the dew off the scope. But even if the dew is off the scope, it's not out of the sky. I'm amazed that the RASA is seeing these 3 stars here. How can this be? It is so covered with dew. How is it able to see even those stars? Because when you look up in the sky with your eyes, there are no stars visible anymore. It looks just like nothing. Now, I didn't go out to the observatory, which is 200 feet away. Look, I bet that's one of the dippers. Oh, wow. It's amazing. How is that doing that? I guess maybe because the scope is raised up another 10 feet. But when I looked out, the sky was just total fog. Larry says, lucky we got this far. Fog alert for Bowling Green, Kentucky too. Dave, do you have to break out a hairdryer for the RASA? Haven't had to do that before, Dave, because of those dew chasers. Ricky, I just looked up. Your temperature hit the dew point just a little while ago. Eli, this is more stars than I would be able to see in New York. Larry, can't view through soup. Dave, it's thinning out. Larry, Charles Messier visits London. Tiffany, I make a delicious split pea soup. Wow, but look, we're actually seeing more. No, it's still not perfect. Look at the Sombrero Galaxy. That's not what it should look like. We should see a lot more with this dark. Yeah, and the last 5 frames have not been stacked. Couldn't align it. Rats, gang. Sorry, man. Well, we're going to count that we saw the Sombrero Galaxy. I'm just going to type in here, worst imaging of the Sombrero Galaxy ever, but we could tell that it was a disk. So much fog.
Observation logged.
Let's try to go back to this swelling spiral and see what the scope does. Is it going to do a complete flip? It is. Dave says, what exposure do you use? 3-second exposure with 400 gain when we're in the live chase mode, like right now. 20-second exposure at 100 gain when we're in the live stacking mode and we're actually observing. Look at that. It's still is right there at the meridian. But I think we did better this time. So this is M49, or M61, sorry, the swelling spiral. The Sombrero Galaxy, also known as Messier 104, is a peculiar galaxy of unclear classification about 31 million light years from the Milky Way. The best part about this is finding out that Tiffany makes split pea soup. Look at this sky view. Is that not the ugliest thing you've ever seen? Look at all that fog. Amazing. We're trying for M61 here. Okay, so this has been our 2 hours, so let's do a 5-minute break while this of course, I mean, the question begs to be asked, will we be able to go on? Messier 61 Swelling spiral, intermediate barred spiral in the Virgo cluster of galaxies, first discovered by Barnaba Oriani. 1779. Dave tried the marathon last night, got 9 in about the same time. Stu, I just snuck a 5-minute break. Well, Stu, you didn't miss much except the fog. I think we're going to be able to see that galaxy there in the middle. Amazingly. I don't see how we're seeing anything. When I looked up, it looked like just solid fog. I wonder if it's because it's hanging right in front of the canopy, whereas maybe over at the observatory, which is 200 feet away from the canopy, maybe it's not as thick over there, you think? Dean says, have you taken the midpoint break yet? No, we haven't. The nap. We were supposed to get the nap, weren't we, Dean? I would say the nap is going to be possible soon because once we get to this, that doesn't even raise until 324. This object raises at 239. So, I mean, that's just on the eastern horizon at 239. What is that? Is that like an alien signal of some kind coming from this galaxy? I don't know if you can see that. It's some kind of a... This galaxy is beaming down a... Which science fiction show was that where they were doing a mining operation? Was that a Star Trek episode? Looks like that galaxy is doing a mining operation on planet Earth. Wonder why they do call this a swelling spiral. Anybody know? So Messier thought this was a comet. Intermediate barred spiral. Looked loosely wound. Fog was thick, though.
Observation logged.
Okay, let's go see what a globular looks like. Maybe it'll be easier to see these globulars. And now we've gotten past a lot of the galaxies. We have one more galaxy left in the whole list. Man, is that it? Oh my goodness, guys. Look at that. I am so sorry. Stu, I saw that yawn, Doug. Oh, guys, I'm so sorry for this fog. I feel horrible. This is M68, globular cluster in Hyades. Look at the strange moonlit fog that it's, the way the fog is catching the moonlight. I still think we're going to be able to see this glob. But then again, I do tend to be an optimist, don't I? Oh my goodness. I see a splotch here in the middle through the fog. Man. Stu, thanks. Stu says, we don't blame you for the fog, Doug. We're just as sorry as you. Yeah, you can tell there is a globular there in the middle, but look, now our live frames have stopped because of the fog. Guys, I hate to say it, but we're going to have to attempt this again on another night. So what did we learn? What I would like to add to the workflow the next time we do this is a little more work in Stellarium so we can see the context a little more of what part of the sky we're looking at. So what I'm going to practice over the next week or so while we're waiting for another cloudless night, because I've already looked and there are no more nights without clouds in the next 7 days. What I'm going to be practicing is slew to the target, start live stacking, look in Stellarium at what part of the sky we're looking at, view the object, make the observation, stop the live stack, go to the next target. That's what I'm going to be sort of practicing so that I can learn to do this like muscle memory, you know? And 2 stars. Remember how the sky looked a while ago? It was just jet black and filled with, you could see the Big Dipper plain as day. Dean says, weather in April is why I'm staying home to watch a stream of the eclipse. Too bad about the fog. What time did you get started? We started late because there were so many clouds. We missed the first 3 objects before they set. Yep, 10:30. Okay, so now we know what we have to do. We'll also practice doing these a little quicker because we want to get, if we can, we want to be able to get at least a 2-hour, hour and a half or 2-hour nap in. I think we would have been able to because, see, by the time we get 2, 4, 6, 8, it's 2:45. So 2, 4, 6, 8. 8 objects from now, we would have been waiting for them to rise. So we could have slept 2 hours because none of them set. None of them will be setting at all. So if we got back up, if we went to sleep at, say, 3 and slept until 5, we would have 37 objects to see in 2 hours. And we're averaging about 4 minutes per object when we don't get stuck. Yeah. So we need to get closer to the 3-minute observing window rather than 7. And we need to get rid of this fog. How many did we get tonight? Well, we're on line 72, but that includes 1, 2, 3, 4, 5, 6 stars to act as pointers. So that means 66. And then take away the first 3, 63 objects. We learned this is very difficult without the perfect conditions all night long. The Messier Marathon was proposed in 1977, wasn't done until 1980 something. Yeah, those last 3 years we've done it. We've been very spoiled, haven't we? Because we've had clear nights all night long. So those have been spoilers. But tonight is not a spoiler. All right, so we'll watch for another clear night. And I'll practice that workflow. And you guys, I guess if you can read up on, I'll put in this description the objects that we viewed, but we'll have to start over again next time to do it right. I'll go ahead and send this one in because, after all, a ton of people don't finish the whole marathon. So I'll send this one in. So do go ahead and tell us your full name, and we'll put you as a part of the watch party. And the one thing that we would ask is you would want to have been here for, you know, the whole time that we've been observing, and then we'll keep you informed as to when we come back for the next time. And we hope you'll join us then, and let's hope we can get, man, it would be great if we could get 109. All 109. We're not going to get M30, I guarantee you. But if we get 109 next time on a clear night, that'd be great. Ricky says, we don't have a fog be gone machine. 1985. So it took them like 10 years before they pulled it off the first time. Tiffany says, yeah, let's keep working on that fog be gone machine. I think, Stu, we have daylight starts at like, we'll lose astronomical dawn around 6:40 at the latest. 6:40. Larry says, still a good night. Yeah, so it would not really be, I think if we come back in 2 hours, I mean, in 4 hours, it'll be sunrise. But if we came back even in 2, I mean, I think this fog is going to be here through morning. Tiffany says, you guys are all so great. Thank you so much. Yeah, we'll try this again. We were early. You know, the real Messier Marathon weekend is not until next weekend, but it's just forecasted to be completely cloudy. So let's try the weekend after. We'll keep watching. Thank you guys for being with us. So sorry for the fog, and do get your name in, and we'll turn this in anyway. and then we'll try again as soon as we get another clear night. Thanks again, Tiffany, everybody, Larry, Ricky, Stu. God bless you guys for being with us. Thanks to the Lord for making all the stars and all the fog. And